assignments before we get started today? Okay. Now what we're covering today is chords and theorems about chords. Now if we have two chords in the same circle or incongruent circles that are the same length, then the chords that then the arcs that they connect are going to be congruent as well. So because chord BA is congruent to CD, arc BA is going to be congruent to arc CD. They're going to have the same measure. We also have the perpendicular chord bisector theorem. If a diameter bisects a chord, it's going to cut it in half. Or more particularly, it's going to say if the diameter is perpendicular to a chord, it's actually going to work out to be a perpendicular bisector and also cut the arc in half as well. So the arc's measure is going to be the same. And if one chord is perpendicular to another chord and bisects it, then the first chord is the diameter. Nope, that's not what I want. I don't think so, but it might be. Any questions on these so far? Now this first problem's not too bad. Because if we look at these two circles, we know that they're congruent because, well, they tell us that the two radii are the same. So these two circles are congruent. They also tell us that the chords here are congruent, which means the arcs are going to have to be congruent as well. So GF is what? 80. So here the measure of arc FG is 80. And that's it. Questions on this here? Let's look at the next one. So here we want to find the measure of FG. I want to find out what the measure of this arc is. And again, we know these two circles are congruent because their radiuses are the same. And they told us that by this right here. We also know that this chord and this chord are the same because, again, they gave us the markers to show that they're congruent. So that means that arc JK is going to be congruent to GF. So what is the measure of arc GF? 120 degrees. And that's it. Questions on this here? Okay, this one has two parts. So the first part tells us that the measure of arc AB is 110 degrees. And we want to find the measure of arc BC. What would the measure of arc BC be? 110. Because the arc that connects AB is 9. BC is also 9. So it's saying that these two arcs are going to be the same. So BC is going to be 110 degrees. That's it. Questions on this here? All right. Erase this here because we're still looking at this for part 2. Now part 2 tells us that the measure of arc AC is 150 degrees. We want to find the measure of arc AB. Well, is arc AB going to be 150 degrees? Well, no. But we know that this arc is going to be the same as this one. Those two are still the same, yes? But what does an entire circle add up to be? 360. So what we can say is that the measure of arc AB plus the measure of arc BC plus the 150 equals 360. Now we just need to solve for the value of x. Well, x plus x is 2x plus 150 equals 360. So the first thing we can do is subtract 150 from both sides to try to get x by itself. If we subtract 150 from both sides, these will simplify to 0, telling us that 2x is equal to 210. And then we would so the measure of arc AB is 105 degrees. And that's it. Any questions on this so far? We like this so far? Using the diameter. So this is the second and third definition that we had. Now looking at this figure, JL is a diameter because it's the chord that goes through the center of the circle. And it makes a right angle with chord HK. So what that tells us is that it's going to cut it in half. So if one side's 7, the other side must also be 7. That's kind of helpful for part A because it wants us to find the length of HK, the line HK. Well, this part's 7 and this part's 7, so the whole thing is. So HK is 14. Now the other part of that definition said it not only bisected that chord, it also bisected its arc. So it means that this arc's measure is the same as this one. So if I want to find the measure of the arc, I just need to find the value of x. So to do that, we can say 11x is equal to 70 minus x. What can we do first? Almost. Because here the x is negative, so we would add. But yes, we would be dealing with that x, so we can add x to both sides. Now negative x plus x is 0. Sorry, no. I take that back. Because what is it? Or two parts. One of them is 11x. What's the other one? Plus x. I wrote. So Briley, you were right. It should be minus x. If I can write it right. Because x minus x would be 0. 11x minus x would be 10. And last but not least, we would divide both sides by 10 is equal to. What do we do next? Right, we plug it back in. So we can say 11 times 7 is. So the measure of this arc is. What's the measure of the other arc? Because we know that they are congruent, they're going to be the same. And what did it ask for? It asked for the measure of HK. So it didn't want just one, it wants. So we would add those together. 77 plus 77 is exactly 154 degrees. That's it. Well, if we wanted the other side, all we'd have to do is subtract it from 360. And I believe that would be 206. Any questions on this here? Let's look at the next one. Well, the first part's not too bad. HK, or KH. 14 plus 14, which is 28. Well, that's not too hard to find. Now they want us to find the length of what? Arc H. Okay, so we want to find this one here. Well, we can do the exact same thing we did on the last one, which would give us the fact that these two arcs are congruent. But once we find it, we can subtract those arcs from 360. So it'll be good to set these equal to each other. So 2x minus 8 is equal to 127 minus x. And luckily this time I wrote it right the first time. Now what can we do first in solving? Add the x, yes. We can add x to both sides. So 2x plus x is 3x. Minus 8 is equal to 127. And then we can add 8. Which tells us that 3x is equal to 135. And last but not least, we would divide by 3. Minus x is equal to 45. So we found the value of x. Now we just need to plug it back in. Now, where we plug it back in really doesn't make a big difference. Because if I wanted to, I could say 127 minus 45. I think I'd get 82. Or we could have plugged it into the other one and gotten 82 as well. Now, if we add those together, 82 plus 82 is what? So that half of the circle is 164. And exactly, we get 196. So the measure of HKL is 196 degrees. And HK was 28. Questions on this here? You like circles so far? Do we want to see another example of one of these here? So if we work this out, what would CE be? 10. And if we solve this here, we would actually get that x is equal to 8. CE going this way, well, 9 times 8 is 72. This would also be 72. Bless you. Any other questions before we look at the last thing we're covering today? In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. If two chords are equidistant from the center, have the same distance from the center, then they are congruent to each other. If two chords are congruent to each other, then they're equidistant from the center. So, looking at this here, they tell us that QR is 16. Well, apparently I'm going to scroll. And ST is also 16. So what that's telling us is that CV and CU are going to be congruent. Because if two chords are congruent, it means they're equidistant from the center of the circle. They are the same distance from the center. In the diagram, QR is equal to ST is equal to 16. CU is 2x. CV is 5x minus 9. Find the radius of C. The radius is the distance from the center of the circle to a point on the circle, yes? Now, for this problem here, I can pick this here, Q to C, that would be the radius, yes? What did that just make? I just made a right triangle, didn't I? Well, any line that goes through the center of a circle is the diameter. And if it makes a right angle to a chord, it's going to cut it in half, yes? So really, if I wanted to say this, let's hit the purple back. I could really say that these are both 8, yes? That's the radius I want to find. So all I need to do is find the x and plug it in, and I have it. So we're using this theorem to find this length. Once we find it, we can plug it back in and solve for the value of r, and use the Pythagorean theorem. Now, according to our theorem, 2x and 5x minus 9 are going to be the same. Because according to the theorem, if two chords are congruent, they're equidistant from the center. They're the same distance from the center. And that's what we're using to find, if I can draw a straight line, this length. And based off 16 and that length, we can use it to find r. So what we can say at this point is that 2x is equal to 5x minus 9. So what can we do first in solving for the value of x? We can minus 5x from both sides. And if we subtract 5x from 5x, those cancel out, telling us that negative 3x is equal to negative 9. Then we can divide both sides by negative 3, telling us x is equal to now that we have that, we can plug it back in. So 2 times 3 is 6. So they gave us a triangle with side lengths of 8 and 6. Does anybody have a guess at what the hypotenuse or the radius is going to be? That's fine. Let's look at a squared plus b squared is equal to our Pythagorean theorem. Now the values of a and b are 8 and 6. Now at this point here, we could plug 8 squared plus 6 squared into the calculator and then take the square root of it. Now 8 squared is 64. 6 squared is 36. 64 plus 36 is 100. And at this point, we would square root both sides, telling us c is equal to 10. So the radius for this is not 6. It is 10. And that's all we have to do. So we use the fact that the chords were equal. Actually, both of the theorems that we had today. The second one saying that since they're equidistant from the center. So our 2x is equal to our 5x minus 9. We used the one we had before to really split this in half to have our 8 and 8 to really set up our triangle. And once we got the triangle set up and found the value of x and plugged it back in, then we can use the Pythagorean theorem to find the radius. Any questions on this here? We have one last one we're going to look at. Now this one here is a little bit different. Because this one here differs from the one we just did in that they already gave us the fact that they are equidistant from the center. Because CD is 12 units away. AB is 12 units away. So that means AB and CD are going to be the same. So we can set them equal to each other to solve for the value of x and plug it back in. Because again, we're still trying to find a radius. So that's the first thing we can do in solving for the value of x. We can add 3 to both sides, yes. And if we add 3 to both sides, it tells us that 7x is equal to 5x plus 10. Then we can subtract 5x from both sides. 7x minus 5x is equal to 10. And lastly, we can divide both sides by 2, telling us x is equal to 5. Any questions on how we found the value of x? Now what do we need to do? We need to plug it back in. Which one do we want to plug it back into? So just say 5 times 5 plus 7. 5 times 5 is 25, plus 7 is 32. But that's the length for the whole length. Do we want the whole length? No, we don't really need it because we only need half of it. We only need from here to here. What's half of 32? So we have 1612 in our radius, yes? Does anybody have a guess at what it's going to be? That's one of the famous, or kind of Pythagorean triples that we've had. That comes, or I said was pretty important. Because it was 3, 4, and 5, yes? If I look at the last one, 3 times what is 6? 4 times 2 is? 5 times 2 is? So wait. 6, 8, 10 is just a reiteration of our 3, 4, 5, yes? Do we have that here? What times 3 is 12? 4 times 4 is? So the hypotenuse would be? Yeah. I know we could say that, but also a squared plus c squared. Now, a and b are going to be 12 and 16. So the first thing we can do is 12 squared plus 16 squared. So 12 squared is 144. 16 squared is 256. Now 144 plus 256, 0, 0, I believe should be 400. And if we square root both sides, square root of c squared is c. Square root of 400 is, and that's it. That's all we have to do for this here. Any questions on any of this here? That's it. That's all we're doing today.